oriented, and the large one I'm going to call
medium.
L.
Large. That's large.
And
okay.
a parallelogram I'm probably going to call P. And I already used S for square, so I think I'm going to use R for rectangle on this, if that's okay with you, because it's kind of a good reminder anyway. Okay, so, and I'm just going to do these. I'm not going to talk them through with you like I should with kids. So I want you to build congruent figures. And instead of the equal sign in the middle, we're going to use that little equal with the squiggle on top, which means congruent. So like the easy ones are, this is baby stuff. Pretend I have the congruent here. And if you're doing it on the dock camera, I just put a congruent sign there, and then I just start moving the pieces in, right, instead of drawing it. But S is congruent to S. And also the areas are congruent. L is congruent to L. Okay, good. Those are the baby ones. How about, are those congruent?
Yes.
Yes, okay. And then I can say, I could actually start recording, which is what they do, with shorthand. Now, I'm not going to draw every picture, but I'm going to say something like S plus S equals R, or 2S equals R, right? Can you see some of the other ones that you might build? Okay. So now I've got S plus S equals P. Well, we already said that, but they have the same area, right? 2S equals M. Where it gets interesting is, and at this point we talk about it, but I let them go. It's like, okay, so if you weren't constrained by that congruent thing, and we're just talking area, then you could say something like 2S equals M, and 2S equals P, therefore the areas M equals P. Area, not congruent, but M equals P. So I'm making an equation there, right? Substitution, right? Substitution.
And you're
See?
also doing combining like terms, where you have one S and one S, and all of a sudden you have two S.
And all of a sudden I call it 2S, but you just say it, right? It just happens.
Right.
It's very, very informal, and that you're recording it, okay? So now I have, let's see, let's break out of those baby ones. There's, here's a good one. S plus R equals S plus P. There's another proof. Therefore, R equals P. What did I just do? Subtraction property of equality, right? I just subtracted S from both of those, okay? The list goes on and on and on and on. And last step is, okay, so now let's find how many unique ones we can come up with. I wouldn't do all these with kids, but they're finding them. When the cool ones happen, oh, bring it up to the dock camera, but I don't ever get that. Okay, let's prove it with math now. You said that the area of P was whatever, and you said R was whatever, okay? Did the numbers work? So when you do these kind of things, which they do to you all the time, okay. They love making crazy things that are hard for you to do on the dock camera as they're calling them out from their seats. But you said that M plus P plus S plus, or M plus P plus 2S plus R equals L plus L. Okay, substitute the values in and tell me if that's true, right? Go substitute those fractions in, combine them, and see if you really do get 1/2 equals 1/2, right? Okay, keep going, okay? Now I'm gonna do kind of what we did a minute ago. This is the last one, okay? And then we'll do the other one. Okay, I'm gonna give a new value to this now. I want you to look at your smallest tangram piece. And this is actually where I would probably move into these tangrams, but we won't fit them in. I'm going to tell you that the area of this piece now is 1/4. I'd like you to build a trapezoid with an area of 2 1/4 and be ready to prove it to me. I'm going to have you work with a partner, and you don't have to use all your pieces, but you're going to need pieces from 2 sets. So pick a partner, partner there,